Conic section ellipse. Introduction. An ellipse is the set of all points in a plane such that the sum of the distances from 2 points foci is a constant. When you go from point F to any point on the ellipse P and then go on to point G, you will always travel the same distance, or F plus G always adds to the same value, and that's ellipse. The two fixed points are called the foci of the ellipse. That's point F and point G. The midpoint of the line segment joining the foci is called the center of the ellipse, and at point O. The line segment through the foci of the ellipse is called the major axis, from point A to point B. And the line segment through the center and perpendicular to the major axis is called the minor axis, which is perpendicular to the major axis from point C to point D, and that's minor axis. The endpoints of the major axis are called the vertices of the ellipse, and we denote the length of the major axis by 2a and the minor axis by 2b, and the distance between the foci by 2c. So the total distance from point A to point B, is 2a, and the distance from point C to point D is 2b, and the distance from F to G, or the two foci, is equal to 2c. Thus, the length of the semi-major axis is A, and the semi-minor axis is B. And the relationship between semi-major axis and semi-minor axis and the distance of the focus from the center of the ellipse, take a point P at one end of the major axis. Sum of the distances of the point P to the foci is FP plus GP is equal to FO plus OP plus GP. Since FP is equal to FO plus OP and is equal to C plus A plus A minus C, it is equal to 2A, and that's the total major axis. Take a point Q at one end of the minor axis. Sum of the distances from the point Q to the foci is FQ plus GQ is equal to square root of B squared plus C squared, and that's FQ, plus square root of B squared plus C squared, that's GQ. And we sum up, that's 2 square root of B squared plus C squared. Since both P and Q lies on the ellipse, by the definition of ellipse, we have 2 square root of B squared plus C squared is equal to 2A, or A squared is equal to B squared plus C squared. And to generate the value for A is equals to square root of B squared plus C squared. And for C is equals to square root of A squared minus B squared. And for the eccentricity of an ellipse is the ratio of the distances from the center of the ellipse to one of the foci and to one of the vertices of the ellipse. Or eccentricity is denoted by E, or E is equals to the ratio of C over A. Then, since the focus is at a distance of C from the center, in terms of the eccentricity, the focus is at a distance of AE from the center, which means C is equals to AE. Standard equations of an ellipse. The equation of an ellipse is simplest if the center of the ellipse is at the origin and the foci are on the x-axis or y-axis. And for foci are on x-axis, that's point F, negative c comma 0, and point G, that's c comma 0. The formula, it is equivalent to x squared over a squared plus y squared over b squared, and it is equal to 1. And if the foci are on y-axis, the formula is x squared over b squared plus y squared over a squared is equal to 1. We will derive the equation for the ellipse shown above in the figure with foci on the x-axis. Let F and G be the foci, O be the midpoint of the line segment FG, and let O be the origin and the line from O through G be the positive x-axis, and that through F as the negative x-axis. Let the coordinates of F be negative c comma 0 and G be c comma 0. Let P as x comma y be any point on the ellipse such that the sum of the distances from P to the two foci be 2a. So given PF plus PG is equals to 2a, and that's equation 1. Using the distance formula, we have the square root of x plus c squared plus y squared plus square root of x minus c squared plus y squared, and it is equal to 2a, or square root of x plus c squared plus y squared is equal to transpose square root of x minus c squared plus y squared to the right side, and that's 2a minus square root of x minus c squared plus y squared. And squaring both sides, we get x plus c squared plus y squared is equals to 4a squared plus x minus c squared plus y squared minus 4a square root of x minus c squared plus y squared, and cancel out y squared and the square of binomials. So x squared plus c squared plus 2xc is equals to 4a squared plus x squared plus c squared minus 2xc minus 4a square root of x minus c squared plus y squared, and cancel out x squared and c squared, or negative 4xc transpose 2xc to right side, that's negative, so that's negative 4xc, and it is equal to 4a squared minus 4a square root of x minus c squared plus y squared, or x minus c squared plus y squared is equal to a minus c over ax, which means we divide everything by 4. Squaring again and simplifying, we get x squared all over a squared plus y squared minus, or divide by a squared minus c squared is equal to 1. Since c squared is equals to a squared minus b squared, thus x squared over a squared plus y squared over b squared is equal to 1. Hence, any point in the ellipse satisfies x squared over a squared plus y squared over b squared is equal to 1. And that's the equation of an ellipse if the center of the ellipse is at the origin. Conversely, let px comma y satisfy the equation 2 with O is less than c and less than a. Then y squared equals to b squared times 1 minus x squared over a squared. Therefore, pf is equals to the square root of x plus c squared plus y squared. And it is equal to the square root of x minus c squared plus b squared. And times a squared minus x squared all over a squared. And simplify square root of x minus c squared plus a squared minus c squared. Since b squared equals to a squared minus c squared, and multiplied by a squared minus x squared all over x squared or a squared. Thus, square root of a plus cx over a squared. And pf is equals to a plus cx over a. Similarly, pg is equals to a minus cx over a. Hence, pf plus pg is equals to a plus cx over a plus a minus cx over a, and it is equal to 2a. Cancel out cx over a and the remaining value, which means pf plus pg is equal to 2a, and that's equation 3. So any point that satisfies x squared over a squared plus y squared over b squared is equals to 1 satisfies the geometric condition, and so pxy lies on the ellipse. Hence, from equation 2 and equation 3, we prove that the equation of an ellipse with center of the origin and major axis along the x-axis is x squared over a squared plus y squared over b squared, and it is equal to 1. Similarly, the ellipse lies between the lines y is equals to negative b and y equals to b and touches these lines. Similarly, we can derive the equation of the ellipse in figure b as x squared over b squared plus y squared over a squared is equal to 1. This is along y-axis and this is at x-axis, or the major axis is at x-axis and this is the major axis is at y-axis. These two equations are known as standard equations of the ellipses. From the standard equation of the ellipses, we have the following observations. First, ellipse is symmetric with respect to both the coordinate axis, since if x, y is a point on the ellipse, then negative x, y, x, negative y, and x negative x minus negative y are also points on the ellipse. Number 2, the foci always lie on the major axis. The major axis can be determined by finding the intercepts of the axis of symmetry. That is, major axis is along the x-axis if the coefficient of x squared has the larger denominator, and it is along the y-axis if the coefficient of y squared has the larger denominator. The equation of an ellipse centered at 0, 0 is x squared over a squared plus y squared over b squared is equals to 1, where c squared equals to absolute value of a squared minus b squared, and c is the distance from the center to the foci. Shifting the graph over h units and up k units, the center is at h, k, and the equation is x minus h open close parenthesis squared all over a squared plus y minus k open close parenthesis squared all over b squared, and it is equal to 1, where c squared is equals to absolute value of a squared minus b squared, and c is the distance from the center to the foci. So this is the equation if it is at the center is at the origin, or 0, 0, and if the center is at h, k, and this is the equation, where c squared is equals to a squared minus b squared absolute, and c is the distance from the center to the foci, x minus h open close parenthesis squared all over a squared plus y minus k open close parenthesis squared over b squared equals to 1. Vertices are a, units in the x direction, and b, units in the y direction, which means this is the distance along x, that's a, and the distance along y, that's b. And the foci are c, units in the direction of the longer major axis, and that's c. Example, graph the ellipse x minus 2 squared all over 36 plus y plus 5 open close parenthesis squared over 16 is equal to 1. And we will determine the center of the ellipse at h, k, wherein center is equals to, change the sign from negative 2 to positive 2, and positive 5 to negative 5. So therefore, the center of an ellipse is at 2, negative 5. And we have 2 and negative 5, and this is the center. And 36, and the value for the denominator for x squared is 36, and the value for the denominator of y squared is 16, and the larger value for the denominator is at x squared, that's 36. Therefore, the major axis is at x-axis, and this will be a squared. So a squared is equals to 36, and b squared is 16. The square root of 36 is equal to a, which is equal to plus minus 6. And the square root of 16 for b, that's plus minus 4. The horizontal major axis for the vertices, 8, which means 2 plus 6, that's 8, and y is negative 5. And for the vertex at the left side, negative 4, that's 2, and 6 from the center. So negative 6 minus plus 2, that's negative 4, or negative 4 comma negative 5. And for the co-vertices, we have 2, negative 1, so that's 2, and negative 1. Negative 5 plus 4, that's negative 1. And the other co-vertices, that's 2, negative 9. So negative 5 minus 4 for b, and that's negative 9. Next, x plus 3 squared all over 25 plus y plus 1 squared all over 81 is equal to 1. Or the center of an ellipse is equal to, change the sign from plus 3 to negative 3 and positive 1 to negative 1. So the center is at negative 3 at x and negative 1 at y. And the larger denominator for x squared is 25, for y squared that's 81. So therefore, the larger denominator is at y squared, that's 81. And the axis is at y axis. Therefore, b squared is equal to 81 and a squared is equals to 25. So the square root of 25 is equals to plus minus 5 for a, and square root of 81 is equal to plus minus 9, and it is equal to b. And the vertical major axis, vertices, negative 3 for x and positive 8. Negative 1 plus 9, that's positive 8. And for the other vertex, negative 3 and negative 1 minus 9, that's negative 10. And this is the point. And for the co-vertices, that's along x-axis, that's negative 8 comma negative 1. And this is negative 3 minus 5, that's negative 8 and negative 1. And to the right, negative 3 plus 5, and that's positive 2 comma negative 1. And these are the vertices for major axis. And for the horizontal major axis, that's x squared over a squared plus y squared over b squared is equals to 1. A squared is greater than b squared, and a squared minus b squared is equals to c squared. And for the length of major axis, that's 2a, and the length of minor axis, that's 2b. These are the summary if the major axis is at x-axis or horizontal. The standard values for focus 1, that's negative c comma 0, and focus 2, that's c comma 0, and the center is at 0 comma 0. And for the co-vertices, that's 0 comma b and 0 comma negative b. And for the vertices, that's negative a comma 0 to the left and a comma 0 to the right. And for the vertical major axis, that's along y-axis, so x squared over a squared plus y squared over b squared equals to 1. It means that b squared is greater than a squared, and b squared minus a squared is equals to c squared. And the length of the major axis is equals to 2b, and the length of the minor axis is equals to 2a. And for the values for focus 1, that's 0 comma c, focus 2, that's 0 comma negative c, and the center is at 0 0. And for the vertices, upward direction, that's 0 comma b, and for the lower direction, that's 0 negative v. And for the co-vertices at the left, that's negative a comma 0, and at the right, that's a comma 0. And to find the latus rectum of ellipse. What is latus rectum? Latus rectum of an ellipse is a line segment perpendicular to the major axis through any of the foci and whose endpoints lie on the ellipse. This is the distance from A to B, and that's latus rectum. Same value at CB. To find the length of the latus rectum of the ellipse, x squared over a squared plus y squared over b squared equals to 1. Let the length of CG is equal to L. So CG is equal to L. Then the coordinate of the point C are C comma L, or AE comma L. Since A lies on the ellipse of x squared over a squared plus y squared over b squared equals to 1, we have AE, that's C squared all over a squared minus L squared all over b squared is equals to 1, or L squared equals to b squared times 1 minus e squared. But e squared is equals to c squared over a squared, the previous equation, and then change e squared to a squared minus b squared all over a squared, and it is equal to 1 minus b squared all over a squared. And change the value for L squared is equals to b squared times 1 minus 1 plus b squared all over a squared. And it is equal to 1, or L is equals to b squared all over a. And this is the length, one half length of the latus rectum. Since the ellipse is symmetric with respect to y-axis CG and DC, so the length of the CD, or the latus rectum, is equals to twice of b squared all over a. And this is the formula to find the value for latus rectum. And the following terms are important in drawing the graph of an ellipse. We have eccentricity. Measure the degree of flatness of an ellipse. The eccentricity of an ellipse should be less than 1. Focal chord is any chord of the ellipse passing through the focus. Major axis is the segment cut by the ellipse of the line containing the foci, a segment joining the vertices of an ellipse. Vertices are the endpoints of the major axis and denoted by 2a. Latus rectum, or latera recta in plural form, is the segment cut by the ellipse passing through the foci and perpendicular to the major axis.